So here's the muscle system and the processes of muscle contraction. Just an overview of the process of muscle contraction is how it starts with the stimulus to the neuromuscular junction to the sliding filament theory and contraction and relaxation of muscles. So the stimulus is the surroundings and something that your sensory neuron picks up as you need to adapt to. The neuromuscular junction is where the impulse crosses the synapse. And then the sliding filament theory is how muscles go from at rest to contracting due to the stimulus and how the impulse gets through to make you understand that you need to move a muscle. And the contraction and relaxation of muscles is how you move and the response that you're giving. So an example of the stimulus could be in a sporting environment, such as catching a netball. This is done by your surroundings and what you're doing. So the environment of playing netball and the surroundings of a ball being passed, your sensory neuron picks up that the ball's being passed to you and you need to react. Onto nerve impulse. This is where the sensory neuron senses an impulse and this is sent to the nervous system. When the motor neuron then receives this, it sends message to your muscles to allow them to contract, which allows movement. The neuromuscular junction sends its impulse to the muscle fibers. This impulse is sent over the synapse. The impulse stimulates calcium to the vesicles containing the chemical here, ACH. ACH travels across the synapse and enter receptor sites, which are on the actin. Muscles at rest. At the end of each muscle fibre, there's sarcomeres. They contract. When the muscles contract, they get closer together, and this is because of how the actin and myosin go against each other. However, when the muscles at rest, sarcomeres have no contraction, so they're far apart, and there's normal resting length between the M line and Z line. So the M line's in the middle, and the Z lines are at the end. Myosin has ATP and is energized, ready to contract with the actin, which allows the muscles to move. So this also means there's no cross bridge between the actin and myosin. The reason for this is the actin is covered by tropomyosin and troponin, which doesn't allow the myosin to make a cross bridge, so there is no contraction happening. Muscle contraction. In muscle contraction, everything that doesn't happen at muscle rest happens. So the sarcomeres get pulled together due to the actin and myosin pulling against each other, and the Z lines become closer because the muscles are contracting, they get shorter, so they're getting closer together, and the M line doesn't move because it's the midline. To sustain a contraction, the myosin needs energy. This is done by ATP being given. When ATP is used by the myosin, it is left with ADP plus P, which is the leftover from the ATP. But to allow the muscles to stay contracted, the actin and myosin must pull against each other, which means that ATP is needed again. But as well as ATP needing to give them energy, ATP is needed for them to let go of each other before moving on again. So they create a cross bridge, and the cross bridge needs to be separated for them to be able to create another cross bridge further along. Ending a contraction. To stop a contraction, the actin and myosin need to separate their cross bridge. As I said, this means ATP is added to allow the parts to separate again, and the impulse that was originally needed to start being able to move your arms to catch the netball needs to stop So this is done by the calcium not needing to be released, and then due to the calcium not being released, the actin binding sites are again hidden. So the tropomyosin and the troponin covers the actin binding sites, which means the myosin can't then rejoin, and that ends a contraction. Types of muscle contraction. So we have isotonic contraction, which is in concentric and eccentric, isometric contraction, and isokinetic. So the differences between the isotonic, concentric and eccentric is the length of the muscles. So in isotonic, concentric, muscles shorten. This is because the tension rises, so they can't like resist, so they have to get shorter. Compared to the isotonic eccentric, where the muscles get longer, the resistance is bigger than the force, so the muscles haven't got as big force, so they get longer. Isometric and isokinetic contraction are slightly different. Isometric happens within strength training, where the muscles do not change length, so they're at constant length, which builds up muscle tension. Whereas the isokinetic is constant speed, so these are changing length, but they're not the same as concentric and isometric. So kinetic is the constant speed, and a lot of people use this in rehabilitation. It uses machines called dynamometers, which help you to move your leg up and down, in one example, at the same speed up and down. So the muscles, say if you injured one of your muscles in your upper leg, it does allow you then to rehabilitate this muscle and improve your strength. That's all for my presentation.